we're asked to integrate the following functions, and in part A, we have to choose our u and ensure that our du is correct. So it looks like x squared plus 5 is the bigger function here, and its derivative will be precisely what's left over. So I'm going to let u equal x squared plus 5, which means du dx is going to be 2x, and therefore my differential is going to be du equals 2x dx. So I'm going to take my integral and I'm just going to switch these two factors here because order of multiplication doesn't matter. So I'll do x squared plus 5 to the 4 times 2x dx. So this guy right here is my u, this guy right here is my du, and so I need to integrate the function u to the 4th du. Well, that's going to require the power rule for integration, and that'll be u to the 5th over 5 plus the constant. And now I will go ahead and plug my u back in since I found the integral. So I have x squared plus 5 to the 5th over 5 plus c. In the next problem, we have 2t plus 4 times t squared plus 4t minus 4. So in part B, we choose the bigger of the two functions, which in this case is going to be the t squared plus 4t minus 4. And so here will be our u. So u equals t squared plus 4t minus 4. So that means du, and I'll just write it from the differential because we know we'll multiply through by dt, is going to be 2t plus 4 dt. So that's exactly what we have left over here. Therefore, my integral, I'll just rewrite it to get the terms together that I need. I need my 2t plus 4 and my dt together. And now I can see that this is precisely du, and I can see that this is precisely u. So that equals the integral of u with respect to u, which by the power rule for integration is u squared plus u squared over 2 plus c, which plugging our u back in, we have t squared minus 4t plus 4 all squared over 2 plus c. Finally, the third integral is going to be the integral of t to the 5th minus 4t squared plus 3 times 10t to the 4th minus 16t dt. So the bigger one here is the t to the 5th power, so we'll let u equal t to the 5th minus 4t squared plus 3, which means our du will equal 5t to the 4th minus 8t. Now we notice that our du doesn't precisely match our remainder, what's left over here. So we notice that this is actually, both of these coefficients are half of what they need to be. So we'll multiply both sides of this equation by 2, giving us the correct expression, which will be 10t to the 4th minus 16t dt. So that means that where I see this, I'm going to replace that with 2 du. So that means I'm going to have the integral of u, which is my t to the 5th minus 4t squared plus 3, times 2 du. Now, constant factors I can pull out, so I'm going to have 2 integral of u du, which we know is 2u squared over 2 plus c. And now these two guys cancel out, so I basically just end up with u squared plus c, and my u is t to the 5th minus 4t squared plus 3 squared plus our arbitrary constant.